a lot to offer here in Cornwall, and I hope that this will be another part of that ability for us to really show that we're here as a hospital trust open for business to work with technology companies, to work with our research colleagues around the region, and to really sort of start to drive innovation in healthcare and technology in the region. My name is James Clark. I'm one of the surgeons here at the hospital. I have an interest in surgical technology, and I hope that I hope that I can bring that energy and enthusiasm here to you today with this symposium. Where do I have to focus this to press it? Where do you have to over here or over there or up in there? Technology. We'll have glitches somewhere along the line, I'm sure. I'll press something and it'll work, or it won't.
It won't work.
Can you run the next slide for me? You plugged in, Pete?
It is, yeah. Sorry, 1 second.
There we are.
Glitching.
See, technology innovation at its best. We have to go back a bit now. Right, that's it. So, I say welcome, and I hope this is going to be the first of a number of these symposiums. And with your support, I hope we can make it a blossoming relationship and a collaboration going forward. I want to just sort of, I just want to go to a line from a very clever chap, the founder and executive chairman of the World Economic Forum, a chap called Klaus Schwab, who wrote that we stand on the brink of a technological revolution that will fundamentally alter the way we live, work, and relate to one another. In its scale, scope, and complexity, the transformation will be unlike anything humankind has experienced before. We do not yet know just how it will unfold, but one thing is clear: the response to it must be integrated and comprehensive, involving all stakeholders of the global polity, from the public and private sectors to academia and civil society. What he was talking about is this, which is the fourth industrial revolution. Now, many people will say there's a fifth, but actually it's very clearly defined economically that we are entering into a fourth industrial revolution. Now, I wasn't aware that there were even more, but there were. We've had our steam, water, mechanical production as so first, of course, we down here had Richard Trevithick, who was our inventor of the steam locomotive. But then it was a division of labour, electricity and mass production, electronics, IT, and the information era. And now we're entering into the fourth, which is a fusion, if you like, of the biological and the machine. It is effectively looking at incorporating all those different processes within cyber physical systems, the metaverse, cognitive computing, artificial intelligence, and really this is what I hope that we will bring to these symposiums today and into the future. It will effectively be marked as the beginning of an imagination age, because it's going to change society as we know it. It's going to change the social fabric as we know it, and we have just started in that journey. And this is from a point of view of economics, whereby the funding from venture capitalists is being directed into these sectors now, today. In fact, it's estimated at being 1.38 trillion, the value of the biotechnology sector across globally, and it's estimated to surpass 4.25 trillion by 2033. We are one of the leading companies, but small size in comparison to China and the US. And although we are looking at an estimated 21.8 billion, there is the US is 552. Interestingly, on the left there, the dark area is healthcare. So it shows that over 50% of that will be focused on healthcare technology innovation. And the estimated growth in the next 10 years will be 12.4% annually. So this is coming from the World Economic Forum. So that really frames what I'm trying to do here, is for us to be that call to arms as a region and to start drawing in on our research fellows in the engineering departments, our life sciences, our clinicians, our companies, our spin-out companies, all of whom we will need in order to take this forward. The healthcare sector is looking, of course, to improve on the healthcare itself. Some of the areas where the focus will be on diagnostic and disease detection, treatment and therapy, so robotics, gene editing therapies, drug development, personalized medicine, chronic disease and remote care, surgical innovations, mental health and well-being, hospital logistics and automation, even the building programs and the buildings and simulation of programs of design flow will all be part of this package. But bringing medtech to the market is extraordinarily challenging, as many of the spin-out companies you might see across today are going to contest to. It's an extremely drawn-out process and requires a huge number of disciplines to work through right from the beginning, from the idea, prototyping, feasibility, right through into regulatory regulations, regulatory processes. So there's quite a lot of going on, and it takes years, but it doesn't have to. And I think we learned something from these guys, from the Ventilator Challenge. You might remember in 2020 when we had a little virus that floated around the world and caused a huge amount of problems. In March, our then Prime Minister Boris Johnson asked the country to rise up and produce 30,000 ventilators. They needed 59,000, they only had 29 in the country, and they needed it by July. So from March to July, the challenge was set to create 30,000. In fact, they reached 24,000 by July and hit the target by August. And that was because they worked differently. And there's lots of lessons that's learned from that. And although, yes, there's a large amount of money and their focus is from all manufacturers was on it, actually, there was a number of lessons learned. One, on the left-hand side, they ran these processes in parallel. So they worked directly with the clinicians and the engineers sitting in the rooms together at the same time. They're all discussing, and issues and problems were all discussed and brought to the table and dealt with. And failure was not considered as a failure, it was considered as a learning opportunity to take the next stage forward. So issues were addressed as it goes along. And so you effectively have already trialled the device with clinical users before you've even gone into the actual regulatory process. So a lot was learned. This was from a company called Penlon. They were set up, they set up the ESO 2, Penlon ESO 2 ventilator. As they ran this, and they've got 14,500 before July, one of the biggest, and they've actually now gone on to be one of the biggest exporters of that particular device. So they made a lot of money, but they learned a lot. One was having a clearly defined healthcare problem. So I think that's one thing that I've learned over the years, is have a clear clinical problem, get the right people around the table, have openness about your failures and successes, and draw back on those and learn from those. Have a fit-for-purpose team structure, so avoiding all the bureaucracy and the process that goes, but just flatline it and be able to just literally talk openly. Everybody, and in fact, what they learned was everybody went into their own sort of, they were focused on their own individual areas. They had no tiered things. They just did what they needed to do and brought it back to the table. So they weren't held back by the red tape, and good communication. And they were skills that really come about with collaboration. And that's what I really want to get out of this particular symposium and future symposiums, is that ability to bring together all these disciplines that we have here in the room, not only disciplines from clinicians, but disciplines across from, as I say, engineers, life scientists, external technologists, spin-out companies, existing corporations, and bring that together, because we will be able to then take those products to market quicker.